Chapter 9, Powerhouse Planning. The structural complex where all the equipment for producing and providing electricity are suitably arranged is called powerhouse. The components of powerhouse are arranged in such a way that higher functional efficiency and aesthetic beauty is obtained. 9.1 Classification, General Arrangement and Layout Plan of Powerhouse. The hydropower station can be broadly classified into three parts: I, substructure; 2, intermediate structure; and 3, superstructure. Powerhouse. 9.1.1 Substructure. Substructure of the powerhouse is that part of the structures which is situated below the turbine level. This part is almost universally below the ground level, and it includes the draft tube, tail water channel in case of impulse wheels, the other natural drainage pipes of wastewater from the powerhouse, drainage galleries. The substructure transmits the load of the structure above it to the foundation strata and is usually a massive concrete construction. 9.1.2 Intermediate structure. It extends from the top of the draft tube to the top of the generator foundation. The turbine, including its casing, the galleries for the auxiliary machines and governor servo motor system, are housed in this part. The turbine floor is generally provided immediately above the turbine level, and it can be used to have an access to the turbine runner and the regulating ring. The turbine floor is below the generator floor and is accessible through 167 stairs. For horizontal shaft arrangement, the intermediate structures may be absent as the turbine and generators are housed in adjacent halls at the same floor. 9.1.3 Superstructure. The superstructure of the powerhouse is the portion extending from the generating floor, called the main floor, up to the rooftop. It consists of the generators and governors, control room, the exciters, and the auxiliary equipment such as needed for ventilation and cooling. The generators themselves are either entirely above the floor level or partially above the floor level. The superstructure consists of walls and the roof with a main traveling gantry crane at the roof level. The control room is often provided with the large glass panel which looks down upon the generator floor. The superstructure also consists of one wing having the office and stores. Depending upon the location, the powerhouse also can be classified as 9.1.4 Surface powerhouse. Surface powerhouse is made above the natural ground level and mostly used in small RR to PRR projects having low head and at the wide river valleys for powerhouse area. The surface powerhouse generally does not have space limitations and needs sound rock in foundation and some architectural design. Proper river training works is important to protect the powerhouse from flood damage. Generally, the surface powerhouse are economical and ease of construction if the river valley is wide and free from land and rock slide, having stable river banks free from the flood hazard and bank erosion. 9.1.5 Underground powerhouse. Under special circumstances such as when gorge or valley forms is narrow, providing not enough space for surface powerhouse, underground powerhouses are worth. Underground powerhouse would be an appropriate proposition when there are more surface hazards like rock slides, landslide, floods, etc. The basic requirements of the underground powerhouse is the availability of good sound rocks at the desired location and depth. Underground powerhouses are safe from air attack during wartime. Important characteristics of underground powerhouse station are its flexibility of layout. The shortest possible layout through various feasible alignments can be drawn up with minimum size of pressure conduits and omissions of anchor and valves. The first fully underground power station was constructed in 1911 in Sweden and operated under a head of 24 M. McKindy, 69 megawatts. Hydropower project is the underground powerhouse of Nepal. 168. 9.2 General dimension calculation of powerhouse. The superstructure of the powerhouse has the following three bays: A. Machine hall or the unit bay; B. Erection or the loading bay; C. Control bay. Dimension of powerhouse. 9.2.1 Machine hall. Length of the machine hall depends upon the number of units, the distance between the units, and size of the machines. For the vertical alignment unit, the center-to-center distance between the units is controlled by the total width of the scroll casing layout. The standard distance of scroll casing is about 4.5 d to 5 d with the turbine outlet diameter as d. The minimum clearance of about 2 to 3 m, so the center-to-center distance between the units is taken as 5d plus 2.5 m for higher specific speeds. This requirement can be reduced to 4d plus 2.5 m. Knowing the total number of units, the total length of the machine hall can be worked out. The additional 4 for the erection //loading is generally equal to minimum 1 unit length by size. 9.2.2 Width of the machine hall is also determined by the size and the clearance space from the walls needed as a gangway. Since the gangway requirements are of the order of 2.5 m, as a first approximation, the width of the machine hall can be presumed to be 5d plus 2.5 m. The width is kept as less as possible to keep small span of the girder and roof structures. In machine halls, the generator placing is not exactly on the center line of the hall but shifted to one side so as to provide adequate operating space for the crane operations on the other side. 9.2.3 Height of the machine hall is fixed up by the headroom requirements, about 2.0 m to 2.5 m, of the crane operations. The hall must have a height which will enable the cranes to lift the rotor of the generator or the runner of the turbine clear off the floor without any. 169. Other machine sets forming obstruction. To this clearance space is to be added the depth of crane girder and headroom for the operating cabin. 9.2.4 Loading bay, also known as erection or service bay, is a space where the heavy vehicles can be loaded and unloaded, the dismantled parts of the machines can be placed and where small assembling of the equipment can be done. The loading bay should be of sufficient to receive the large parts like the rotor and runner. The loading bay floor will be having a width at least equal to the center-to-center distance between the machines. 9.2.5 Control bay. It is the main room and control other equipment like runner, gate valves, generator, etc. It may be adjacent to the unit bay, i.e. machine halls, as it sends instructions to the operation bay from where the operation control is achieved.